Everybody knows. Everybody knows where is Mumbai? Which state it is?
Maharashtra.
Maharashtra, yes. So I have done a 5-year course in it's a 5-year master's course. So they give you it's like a combination of bachelor's and master's, BSc plus MSc combined. So 5 years I spent there. I have done masters, and after that I have been teaching in different places. And so I was teaching in Byju's. I guess many of you would have heard of it. It's an online education company. How many of you have heard of Byju's? Can you raise your hands? Yes. Okay, nice. So yeah, so I was working there. I was making content, making this chemistry content for school curriculum, and I've been teaching also. So okay, my question is, how many of you actually like studying chemistry? So raise your hands. Okay, that's a very good number. How many of you don't like chemistry? You can be honest. It's okay. All of you like it? You're sure? There's nobody who doesn't like it. Okay. So, okay, let's just start. So what is chemistry like? Why do we study chemistry? Yes. Anyone wants to answer? Why do we study a subject? What is this subject all about? Um, what what do we study in chemistry? Yes, anyone wants to say? So yeah, I think somebody said it is the study of the matter around us, right? So I was talking to this SGP students last time. I was telling them that see, chemistry is everywhere around us, right? So um, the air which we breathe, right, that itself is made up of so many compounds, right, and elements. So in air we have oxygen, nitrogen, right? We have carbon dioxide, maybe some hydrogen, maybe some carbon monoxide. We have so many gases, right? So these are all basically elements, compounds which we breathe in. So the air, the very air which we breathe, which gives us life, is basically chemistry, right? The food which we eat, right? So all the different substances which you have, carbohydrates, proteins, minerals, vitamins, those are all some kind of chemical, right? So in our body itself we have so many chemical reactions happening, right? We are actually alive because of all those chemical reactions, right? So the food which we eat, it becomes energy, right? How it becomes energy? How does the food become energy? Anybody has any answer, any answer to this? How does food become energy? Okay, anyone can answer if they want. They can come to the microphone and answer.
It contains hydrochloric acid, sir.
So yeah, okay. So basically, see, what I'm trying to say is that yeah, food gets digested, and ultimately what happens, when you burn something, right? Like carbon or some wood, if you burn, or like the cooking gas which burns, it releases energy, right? Like heat which you see that cooks food, right? If you burn like a cooking gas, or if you burn some wood, so burning creates energy. So in the same way, the food which we eat, actually, in a way, we can say that it burns inside, our body. There is a combustion. It's called combustion, right? Another name of burning is combustion. So combustion happens in our body. The food gets combusted, or it burns, and it releases energy, right? So you must have noticed that the when you breathe out, if you notice your breath, it's little warmer. The breath which comes out, right? It's little bit warmer, so that is the heat. So the oxygen which we take, it basically, that oxygen combines with that food, it burns that food, and that releases energy, right? So in the same way, the oxygen combines with your fuel, like your gas, petrol, wood, all this is fuel, right? So that the food itself is like fuel, and oxygen which we breathe in, it burns that fuel, or it burns that food, and it releases energy, right? So that is a chemical reaction, right? So what is the most basic chemical reaction of burning? I'll just share my screen. Okay. Okay. So the basic, whenever somebody says what is burning or combustion, we can simply say that, some carbon is there. That carbon when burned to give CO2, right? And some energy is released, right? So essentially in our body also, that is what happens. This can be, this carbon can come from some fuel, it can come from food, right? So it could be anything, right? That will give, um, it could be like petrol or cooking gas, right? All these things. So basically, what I'm trying to say is that, there is a chemical reaction happening in our body. That's one, and there are so many other reactions. All the food which we eat, it gets digested. All the, protein, breakdown of protein, fat, everything, and all the processes which are happening in our body, all are chemical reactions, right? So chemistry is all around us. With it's involved with everything, which we do. And okay, so let's come to okay, one more thing. So okay, everybody would have taken some kind of medicine, right? If you fall ill, if you have fever or something, you take some kind of medicine. So that medicine also is basically a chemical, right? And that chemical goes inside our body. There is some reaction happening, and that acts on the, whatever disease. So yeah, so that is also chemistry, right? So chemistry is a vast subject, and it's a practical subject. It's about things happening, chemical reactions happening. And if you study chemistry, if you do masters, or if you go into research or in industry, you can what you can do is you can become a chemist, right? So it's a and what chemists do, they make these chemicals, like medicines, or chemicals in day-to-day life, like paint, soaps, detergents, um, many things. Like food itself has so many chemistry involved in it. So um, you can become a chemist, and that this could be a good career option also. So if you make some medicine which can cure a lot of people, then it's a very big thing, and so many people need so many medicines. So it's a career option. It's a vast field, and somebody could choose to go into chemistry, as a profession also. Um, so as I said, chemistry is all around us. There are so many reactions happening. So we start the study of chemistry for your grade from looking at different kind of matter around us, right? So what are different things? Whatever you have around you, we call it matter, right? You have chair, tables, pen, pencil, paper, fan, right? All this is matter, right? So how do we define matter? What is the definition of matter? Anyone wants to say it? So, right, whatever we see around us, basically it has two properties. It will have some mass and it will occupy some space, right? Whatever object which you see, water, school bag, like here they've shown, and fruits, vegetables, chair, everything has, it will have some mass, right? And it will occupy some space, right? So these are two basic properties of matter: mass, and it will occupy mass and space. So we say anything which has mass and it occupies some space, we call it as matter, right? um, can you tell me some example of something which is not matter, like something is which you there is something which you will say that maybe it's not matter?
Yeah, enough.
Air? You sure? See, if I heard it right, I think you're saying air. Air is basically you can trap air in something. It occupies some space, right? Like in a balloon, if you look at the air in the balloon, it occupies that space of the balloon. So there is something. You can feel it on your face, right? Air is something which is it's actually matter because it is made up of these oxygen, nitrogen, carbon dioxide, all these things, and dust particles and so on. So air is basically consists of so many things which is again matter. So, and it has also some weight. You can also measure the weight of air. How you can measure? See, I'll tell you. Suppose you have an empty balloon. You have a balloon which is not inflated. You can take its weight and you can put air in that balloon and take the weight of the balloon after putting in air. You will see there is a slight increase in the weight because of the air. Very small, but yes, it will have certain weight. So even air has certain weight. So air is also matter. Any other example can you think of it?
Elements, Anna.
Hmm?
Elements.
So elements are what? Are you saying they're matter or not matter?
Not matter.
Okay, so see, whatever, okay, it's a, yeah, good thing you said it. See, whatever matter we are discussing, right? What is matter? Ultimately, it is made up of those atoms and elements, right? Whatever you have, like, like discussing air or chair, table, everything is made up of certain substance. So that also we'll see when we study the chapter. It is made up of um, elements itself. So elements are actually matter. Elements are something which make up the matter. So elements themselves are also matter. Okay, actually, if you have to say, if you have to say something which is not matter, maybe you can say like something like a feeling. Um, suppose you say love, right? A feeling, maybe you can say it's not matter, right? You cannot wait. You cannot say, okay, it occupies some space. So something like feelings, you can say, they are not matter. But with rest everything which you can see, feel, touch, everything will be called as matter. Now matter, we saw that I think you would have seen it can be classified based on how physically it looks. We can have matter in three forms, right? You must have studied solid, liquid, gas, right? Based on the physical nature of the matter, we can classify it into solid, liquid, and gas, right? So what is the difference between solid, liquid, gas?
And the particles of a solid is very tight, and a liquid is light looser than solid, and gas is it's having more space, it's not tighter, it's so loosing.
Yes, yes. So you would have seen solid, liquid, gas. We have you would have studied. So okay, just look at this animation, right? Just remember, it's a very important animation. Whenever you think about solid, liquid, and gas, you should have this picture in your mind, right? So these blue balls are basically representing the particles, right? Particles, it could be atoms or it could be molecules of that substance. So like she was mentioning, so you can see in solid, the particles are vibrating, right? They are not actually moving, they are vibrating, right? So vibration means, they are just at their position and just moving, maybe very fast or very slow, but they're moving at their own position, they are not moving. In liquid, there is some movement, right? So they are moving little faster than in solids, but the particles are still they are moving, but not very fast. And in gas, you can see the particles are moving very fast, right? And so this is the comparison. These are the particles of gas, liquid, and solid. One more thing which I can notice is that if you see the particles here, they are just confined to this particular volume, right? The volume is fixed, right? They are vibrating within this volume, but in liquid, they are little more, they are moving, right? Still the volume is fixed, but they can move, right? Here the particles are moving all around the space of the container. Let's say this is the container, so the particles of gas are moving in the space, it is occupying all the space of the container, right? So we say that solids have fixed volume, right? Liquids have fixed volume, but their shape can change depending on different container. It will take the shape of that container because the particles can move little bit, right? But their volume is fixed. And gas can take, like, whichever container you put the gas in, it will take the shape of that container. It will fully occupy that container. If the same gas I put it in a bottle, it will take the whole space of the bottle. If the same gas, if I put it in a bucket, it will take the space of the bucket, right? If I put it in a small glass, it will take the space of that glass. So because of this movement, the gas spreads all over, right? So that's why, if you put some perfume, it's like a gas, so it spreads all over, and people can smell from a distance because the particles move very fast and they spread all around in the air, they mix with the air, the perfume or incense stick or smoke, right? These kind of things. So this is one way to so all matter around us, in one way you can say that it can be a solid, liquid, or a gas, right? All matter around us, we can divide it into these three types. This is one way to see it. Another way to see it is in terms of pure and impure substance, right? So one way is you look at the matter as solid, liquid, gas. Another way to see it is that you can look at it as a pure substance or an impure substance, right? So what is the difference between pure and impure substance? Somebody wants to?
Pure substance is called a homogeneous. For example, salt in water, And impure substance means it's called heterogeneous, Anna. Example,
Okay.
sand and
Okay,
water.
okay. Wait. You are okay. Somebody else, any other school, they wants to answer. NGK, Kadlor. Let's hear from other students. Pure and impure substance. What is the difference?
Pure substance is made up of only one kind of particle.
Okay. Okay. So see, yes. So see, for everyone should listen carefully. See, in day-to-day life, we say pure substance. We say like there is a pure water, impure water, or maybe some pure milk, impure milk. In day-to-day life, we use these terms. Something which is clean and which maybe we can consume or we can use. We say impure. We say pure, or something which has some bad substance or some harmful substance, we can call it impure. That is day-to-day life. But here in chemistry, in scientific terms, there is a difference. Okay, between pure and impure, there is a difference. Pure substance, remember, pure substance is made up of only one kind of substance. Okay, pure means it is made up of only one kind of substance. Okay, and impure means it's a mixture of two or more different things, right? So pure substance, only one kind of particle or one kind of substance is present. Impure means it's a mixture of more than two things, right? Now give us some examples. Can you give some examples of pure substance?
Some elements like oxygen, sulfur, they are pure substance.
Right. So if you take only oxygen in a container, if you take only oxygen gas, that is a pure substance, right? If you take only carbon dioxide gas, that will be a pure substance, right? Suppose you take the water which you drink, drinking water. Is it a pure substance?
No, Anna, it has hydrogen and oxygen, so it's not a pure substance.
Okay, wait. So one important thing all of you should understand is, see, when I say, when you say, suppose I say drinking water or tap water, right? So, okay, just a second. Okay, why is not moving? First one second. Okay, wait. Yeah. So when we say drinking water and tap water, so what this is, water is H2O, right? Water is H2O, and H2O is what? This is basically when we say one H2O, this is a molecule, right? Molecule of compound. So water is a compound and H2O is the molecule of that compound. So when we say water, that means suppose you have water in this container, that means you have so many H2O, molecules. It has, if you take a glass of water, it has so many H2O molecules, right? That is what water is. It is made up of many H2O molecules. Is there anything else in water? Is there only H2O or there is something else also?
Anna, minerals.
Right. So you can have some minerals. You can have some minerals, right? Like sodium, potassium, right? You can have some minerals. What else you can have? Okay, so there might be some gases also.
Atoms.
Okay, okay. Okay, just 1 second. I'll just open another page. So yeah, till then you tell me what is the what are different things in water, drinking water. So you have H2O molecule, then you have um, you have minerals. What else is there? Okay, so you also
Atoms, Anna.
okay, okay. So you have some
So,
you can have some gases also. Okay, you can have some gases, like you will have some oxygen, you can even have some carbon dioxide, right? So what we see is that the drinking water actually which we have is actually a mixture of so many things, right? One is H2O itself, right? Other than that, it has some gases, it has some minerals. So the water which we have, which we drink or use in daily life, it is a mixture. It's not a pure substance, right? Even though we are drinking it, it's like in day-to-day terms, it is pure. But in scientific terms, in chemistry, we will say it's an impure substance because it is a mixture of, right? It's a mixture of so many things, right? So this is basically a mixture, right? Or we also mixture is same as impure, right? Now, have you heard of distilled water?
Yes, Anna.
Right? What is distilled water?
Anna, there's no impurities and particles in it.
Hmm? So, suppose we have, let's say we have distilled water. Okay. Suppose we remove everything else and we are left with only H2O. Okay. Suppose we are left with only H2O. Remove everything other than okay. Let's just do not call it distilled water because even I think distilled water can have some impurities. Okay. Suppose uh, suppose you have your tap water, okay, and you remove everything other than H2O molecules. You have only H2O molecules. Then you will say that this is pure. Okay. Then only you will say it is a pure substance. So pure substance means only one kind of thing is present. Maybe it's just H2O, it is just oxygen, it is just nitrogen, right? That is a pure substance. And if it is consisting of more than one kind of substance, it becomes a mixture, right? So can you give examples now of some pure and impure substances?
Milk is a impure substance.
Hmm?
Milk is a impure substance.
Milk is an impure substance. Yes, maybe you can drink it. It's good for your health, but in chemistry, in scientific terms, you will say that it is impure because it's a mixture of many things. It can have some water, many fat or so many things, right? So, can you give more examples? Can you give examples of pure substances?
Drinking water.
Hmm? See,
Water.
So drinking water, I just said, actually it's not a pure substance. It's an impure substance because it is a mixture of so many things. It has H2O, it has gases, it has minerals. So it's actually an impure substance in terms of chemistry.
Sir, I am saying ink in water.
What?
Ink in water.
Ink in water. Okay. Sorry. Yeah. So ink, if you mix in water, becomes a mixture, right? So, right. Yeah. So pure substances can be, yeah, you take any gas, like if you just have carbon dioxide gas.
Oil Anna.
Yeah, oil, yes. If you have like a pure oil which has nothing else mixed in it, we can say it is a pure substance. So pure substance basically will have only one kind of particle. Impure will have more than one. Okay, I'll give you some examples here. Okay, so right, so pure substance can be, let's say you have only hydrogen, right? So only hydrogen gas. Suppose in a balloon you fill only hydrogen gas, right? That will be a pure substance. Or let's say you have only CO2, right? Only carbon dioxide gas, right? That will be also a pure substance, right? So remember, this is only one kind of, it should not be mixed with anything else, right? All right. So H2O, when we say, remember H2O, this is one particle. Okay. This is what we call it as one particle of, right? So H2O is one combined entity. It's not hydrogen and oxygen separate. Right? It is combined through bonds. It is one single substance or one particle, right? So when we say water, we say it is made up of H2O molecules, right? This is one particle, right? And so mixture, okay, it is, or I'll write this, consists of two or more pure, okay, so mixture will be made up of two or more pure substances. So it could be something, you can have a mixture of, suppose you have a mixture of, okay, let's take this example. Somebody was mentioning, what is air? What all things are present in air?
Hydrogen, oxygen, carbon.
So oxygen, CO2, nitrogen, right? All these things are present, right? So we say this is a mixture, right? Right? So milk is also a mixture, right? Give more examples of mixtures.
Anna, food item, Anna. Food items we eat. We will put lot of proteins items and lot of vegetables. Like that, food
Yeah,
item with mixed items.
yes, like I mean, yeah, most of the food items will be a mixture of many things. You can have cold drink, that is also a mixture, right? You can have, what else you can have? Suppose you're having biryani, right? That is also a mixture. It has so many spices and rice and this and that, right? So when it is made up of many substances, we say it's a mixture, right? Or you can have yeah, any two gases, if you mix, that becomes a mixture, right?
Soil
Yeah, I was thinking about it. Yes, soil is also a very good example of a mixture,
perfume anna.
right? What perfume?
Sir, lemonade.
Yeah, if you mix lemon, sugar, water, you can make this lemonade, mixture.
Salt.
Cocktail anna.
Yeah, right. Ice cream is also a mixture, right? So yeah, you can have so many examples. And right, air is also a mixture. Drinking water basically is a mixture, right?
Anna, some kind of hard metals, plastics are also mixed.
Yes, mostly plastics are also mixed with different things, but you can have pure substance in plastic as well. Okay, fine. So I think, yeah, we will just conclude with this much only today. Okay, so next class we will continue from here, and we'll look at elements, compounds, how are they related to these pure substances and mixtures. Okay, so okay, fine, we will close today. For today, this much is enough. Okay, okay, all right. If you have any doubts, we'll see in the next class. Okay, okay, namaskaram.